In this video, I will go over the homework that follows lecture 12.1 called Using the Tables of Integrals, but in general, we are at the end of our journey of learning how to integrate. So I hope you watched this lecture that covers the strategies for integration, because this is what you have to go through before you go and search for other ways, such as using a table of integrals. And let's go ahead and get started with the homework. So here's what the homework looks like, and the question is pretty much straightforward. We are asked to identify the pattern and use the correct formula. In our case, it doesn't look that like we can use any of those patterns yet, so we may have to add like an extra step, like fill in this missing link, and such link could be a substitution or integration by parts or some other manipulation of the integrand that will connect what you have with what you know. And here a substitution will be x squared, and we're going to have dt is 2x dx, and this whole integral will become dt, and here we have x to the 4, but x to the 4 is just t squared, and it will help us to, instead of 16, write it as 4 squared. So now, in order for you to see the answer, you have to imagine your t being u and your 4 being a, and then this problem is pretty much the same as, it's like identical to this problem, for which we do have the answer. So the correct answer is the option number 4. Similarly, we can clean up this integral to make it look a certain way. And to clean this one up, we're going to take 6 out, and we're going to also take 6 from the denominator. So to take 6 from the denominator means we have to factor out the 36. And here we're going to have 81 over 36, which is 9 over 6 squared. So the pattern, again, in order for you to see the pattern, you have to think of x as your u, and you have to think of your a as 9/6 or 3/2, and that's what's gonna connect what we have with, oh, here we're not just choosing it, we actually have to do it. So according to the formula, so okay, I thought we were done, but let me move this out of the way. This is like literally a thought bubble. Now, according to the table, or according to this piece of knowledge that we're getting from this hint, we have an integral of du over square root of u squared minus a squared to be equal to ln of u plus square root of u squared minus a squared plus c. And now we can pretty much summarize the answer. If instead of u we write x, if instead of a we write 3/2, we should be getting the answer. That's how we use the tables of integrals. So the answer here is ln absolute value of x plus the square root of x squared plus 9/4 plus c. Not sure how the minus became plus, so it's actually minus here. This is a glitch. The answer that we provided is correct because they just the Newton actually not taking out the 6. So as you know, ln of 6 times something will be ln of 6 plus this, and this can become part of the constant. So our answer is correct. So but I am going to reach out to Newton and let them know that their code is evaluating the answer incorrectly. Here's the next question, and let's go ahead and see what we can do here. And in order for us to be able to do something, we have to have variable inside of sign instead of some function. So this leads us to the idea of substituting 1 over x to the power 3 as t. So dt will be equal to negative 3 over x to the power 4 dx. And what we're going to do next is we're going to take out 9. Instead of x to the power negative 10, I'm going to write it as x to the power negative 3 squared times x to the power negative 4. So you should be able to see how 1 over x to the power 10 dx now becomes 1 over t squared. Actually, there is no 1 over t squared. It's just t squared. Here we have sine of t, and we have we don't have dt, but we have dx over negative 1/3. Not dx, but dt. And taking out negative 3, we now clearly see which pattern to use. All we have to do is to think of u to be t, and to think of n to be equal to 2. And then we can use this formula that says integral of u n sine u du is equal to negative u to the power n cosine u plus, we have recursive formula. And so we're continuing here. We still have negative 3. We now have the following. So we're going to plug in t squared cosine t plus 2 integral, it's going to be t cosine t dt, and here we're going to actually push it a bit further, and instead of t integral of t cosine t, I'm just going to use that very second formula here. So it's just going to be 2 cosine t plus t sine t plus c. And the last step to do is to reduce, not to reduce, but to replace t with what it stands for. And t stands for 1 over x cubed. So we have negative 1 over x to the power 6 cosine of 1 over x cubed plus 2 cosine of 1 over x cubed plus 2 t sine of 1 over x cubed and plus c at the end. So the answer is, I'm going to distribute the negative 3 over, so we have 3 over x to the power 6 cosine of 1 over x cubed plus 2 cosine of 1 over x cubed. Remember, I'm distributing the negative 3, so it's going to be negative 6. And then, again, distributing negative 3, so I have negative 6 over x cubed sine of 1 over x cubed plus c. So the fact that you have table of integrals available to you, it doesn't make the problem easy. It makes it doable, maybe more straightforward, but certainly not easy. All right, so let's move on. We have a similar problem to the previous one. And the first step is to do the substitution. So the substitution is t is equal to x to the power negative 5. So dt will be negative 5 over x to the power 6. So x to the power negative 11 is now t times x to the power negative 6. So it should be, we should be able to combine it with dx and kind of exploit that pattern. So what we have now is 7 can go outside. We have integral of cosine of t. Instead of x to the power negative 11, we're going to write t, x times to the power negative 6 plus x to the power negative 6 can be combined with dx, which gives us this pattern. And we take out the negative 1/5. And by thinking of u as t, and that's pretty sufficient, we're going to use the fact that integral of u cosine u du is equal to cosine u plus u sine of u plus c. So this integral now becomes negative 7/5 of cosine of t plus t sine of t plus c. So instead of t, now it's time for us to plug in x to the power negative 5. And that's the answer. So let's type it up. we have -7/5 cosine of 1 over x to the power 5 and that should do it. Let's do question number 5. Were they always giving us these ideas? I didn't even read the problem, to be honest. Actually, oh yeah, this is a different problem, right? So they tell us, they suggest us to use the substitution and the formula. They give us the formula, so now we just have to do what they told us to do. What I don't like about this suggestion is that they suggest us to use letter u as a variable. I generally avoid using u as my substitution variable because we may need it for integration by parts. So here we have x to the -2 times x to the -3. I guess we should be able to like stick it in there, right? So we have, let's say if this is dx, then this whole thing becomes u times -1/2 du, right? So that's kind of the pattern, taking advantage of the pattern. So the whole integral now becomes -7/2 integral of u sine of u du. And according to the formula that they suggested, this is going to be sine of u minus u cosine u plus c. Actually, plus c can be outside. And the final answer is -7/2 sine of 1 over x squared minus 1 over x squared cosine of 1 over x squared plus c. That's the answer. Here we just have to recognize the pattern. And the pattern so in order for us to see the pattern, we have to do this substitution. We have to set t to be e to the power 8x, so that dt is 8e to the power 8x dx, and that t squared is now e to the power 16x. So that's the substitution. Now 1. So we can also take out the 1/2, and what we have left is dt over, we have 64 times 64 minus t squared to the power 3/2. And now if you just think of u as your t and a, so again, it doesn't help us to think of it as 64. We probably want to think of it as 8 squared. So if you think of a as 8, then you can use the following formula that says that integral of du over a squared minus u squared to the power 3/2 is equal to u over a to the power 4 a squared minus u squared plus c. So according to this formula, this integral now becomes 1/2. U is t. A to the power 4th is 8 to the power 4th. Square root of 8 squared minus t squared plus c. So, sorry, not done, because t is, and we may want to compute what 2 times 8 to the power 4 is. 2 times 8 to the power 4 is 8,192. T is e to the power 8x. And here we have square root of 64 minus e to the power 16x. So again, it may not be easy, but it's definitely more clear path from not knowing what to do with the original problem to actually getting some answer. We may not like the answer, but it is the answer. And that's it. So this is how we use tables of integrals to do integration. If you have any questions about that, please feel free to reach out.